Okay, in our last episode, we got our project up and running, and our game here is already working with the character moving on the screen. So now, next step, let's fix this display resolution and the zoom of the camera. Our character is too small. So this measurement here represents our room size. If we change here, it changes our room size, and if we run the game, the window will follow the room size. And we don't want that. If we put a background here, let's put a sprite that I imported. We have this sprite here representing our map, and if we run, the player will be able to see the whole map already like this. And we don't want that. We just want to show one portion of the screen. So let's change it. Let's make the room settings here the same resolution of the sprite, which is this one. So let's make our room 960 by 360. Now it's fitting the map. And the screen is now too small. Let's zoom the screen up. And to do that, we'll open the viewports and camera. We'll enable the viewports and enable the viewport 0. And now you see this has this white border here, but it's the same resolution as before. Let's match the resolution here, 960 by 360. Now our viewport is the same resolution as the map, and 960 here by 360. If we run the game now, nothing will change, because the viewport here represents the size of the screen. This screen here, this window, has 960 by 360. So we will make our camera now smaller. Let's make it 250 by 250. Now our camera is taking this portion, and it's gonna take this smaller screen and stretch it to this whole screen. So let's see how this works. Now we have the part of the screen that we want to show, but it's stretched out. So let's fit our screen here and see what happens. Perfect, right? We have our smaller screen here, and it's not showing the full map, but it's still too small. So let's pick this window here and stretch it up. Let's make it 500 by 500, and let's run it again. Now it's better, but I think it can go bigger. Let's make it 1000. 1000. And now it's perfect. Almost looking like a game now, right? And this is how you should work with this. The resolution of the window must be an integer scaling of the camera resolution. Because if we don't go with integer scaling, you can see how the pixels here are perfect. If we go with 900, it will break the integer scaling, and the pixels will look uneven, and the graphics won't look very good. If you notice here, his eyes, let me put him, his eyes are kind of changing in size, right? It's like small and then big and then small, and the pixels are overall uneven. So this is why you should use always double the resolution of the screen. And this resolution is also not right. If we go here and see the Super Nintendo resolution, it uses 256 by 224. So let's take this resolution, 256 by 224. And to get the integer scaling of this resolution, we'll take that and double this resolution. Double it again. And the other resolution. Now if we run, we have the integer scaling of the Super Nintendo resolution. Perfect, right? Now we should take an important decision. If we go here and see the classic Bomberman games, the stage is one screen. You have just to beat the screen to beat the stage. But on Super Bomberman 2, the stage is quite longer and the screen follows the player around, like a side-scroller. So we should go with a side-scrolling stage or with a fixed camera stage. So to decide that, I'll be opening a poll in the community tab. I ask everyone to vote and help me decide what we should go with. Fixed screens or a side-scroller stage. For now, let's continue with a fixed screen and a square aspect ratio. Now our movement is kinda lame, right? He's moving too fast and it's not smooth at all. Let's fix that. Now the movement code that we have here is not ideal. The keys are all scattered and each code is in a different window. Let's put that all together and make a more personalized code. Let's delete all of the events and we'll add a create event. This event here is parameters that are created with the object when the game starts. Each time the object is created, it will create all of the variables here. Variables are small boxes with informations, like here, let's put like HP, and it can be 1, 2, 3, 4, it can be any number, right? And when you take damage, it decreases the HP. Or we can determine if the player is alive by determining it's a boolean and it's only true or false. You can be only alive or dead. We can define the variables through here, but I like defining the variables through text, which is better. So our first variable will be if the player is alive, which is true. And what else we can do? We can get his horizontal speed, which we will call HSP, horizontal speed. We'll set it to 0. His vertical speed, VSP, we'll set to 0 too. And here's a bunch of variables to define the keys that the player can press. Key left, key right, key down, and key up. Now let's open a step event. This event, it happens every frame. It will make all of the instructions in this window, and in the next frame, it will repeat the instructions. So if we put here x equals x plus 10, the character will, each frame, he will run one step to the right. See? So in order to make our movement, we will make the input like this. Keyboard check. Here we have check, pressed, or released. Remember that last episode we have the key pressed, key down, key up. It's the same thing here. If released is key up, pressed, and check is the keyboard press, right? Key down is key check. So let's put here VK. It's not VK's channel, guys. Is VK left. If we click with the middle button here, it will open a window that will take you to the Game Maker manual and it will explain what this is. So this is for the keyboard keys, right? Each key has a code and you can see the code of the key here. And this gives you much more freedom of what keys to use. So we'll use key left, key right, key down, key up. Let's put that here. We have our keyboard key set, but let's also make it into the variables that we set before. Key left, key right, key down, and key up. Left. And now we have our keys coded. If we middle click in this function, it will open the manual. And here it says that this function, keyboard check, will return a Boolean value. It means that this value will be true or false. So if we press left, key left will be set to true. And if we release key left will be set to false. Now let's set some extra variables. Let's tell his speed, and you'll notice here that the name is green. It's green because this is a built-in variable, and built-in variables are kinda lame because it's already pre-coded in GameMaker and they will behave in a specific way. This manual here says that the speed will move the object in a certain direction. So let's put here the speed equals 5, and let's put direction to 90 degrees. The character will move up, and we don't want that. We want to be able to control his speed independently. So let's make it m speed so that it won't be using the built-in variable. And now, even with m speed set to 5, he will still be stopped in the center, because it's not a built-in variable and we can do whatever we want with it. Actually, let's make it even better. Let's make it SPD. It's shorter and easier to use. So let's make our movement code. HSP equals speed multiplied by key right minus key left. Let me explain this code now. HSP equals 5. Why 5? Because we set the speed to 5. Multiplied by 0 minus 0. And this means 0 because if we middle click here, it will show in the manual that the keyboard check function returns a Boolean value, which is 0 or 1, true or false. So if you're not pressing any key, this will cancel everything out and HSP will be set to 0. If you're pressing right, it will be set to 1, and HSP, it will be equals 5 multiplied by 1, which is 5, and he will move right. And if you're pressing left, it will be like HSP equals 5, and it will be like minus 1, and he will move left, correct? And finally, let's make our movement happen by setting x equals x plus HSP. If we run the game now, he's not moving, and let's see why. The reason why is that because it's a step event, it will make everything happen in order, right? So here we're setting the HSP to the correct value, which is our movement, left or right. But here the code is setting everything back to 0 again, which is making HSP 0. So let's remove this, and now it will work. Now it's working. And this is very important. You should always pay attention to the order of code. Sometimes if I have the code, if I have this wrong line of code happen before the correct line of code, everything will be fine. See, it's working fine. Because the wrong line of code is happening before the correct one. So the correct line is overriding the wrong one. If I have the wrong line of code happening after the correct one, it will be overriding the correct values to the wrong values, and it will mess up my code. Now all we have to do is repeat the same code for the vertical movement. Like this. If we test our game now, let's run the code, and we have a much better movement. And he's a bit too fast, right? And this is the advantage of this. The speed is set to 5, so let's just tone it down to 2, and now the movement will be much better. See? That's the beauty of this. You can easily customize your code by just changing a few numbers, instead of going on each screen and changing the numbers manually. But the game is only being controlled by the keyboard now. What if I want to add a gamepad? Well, we have a function for that, gamepad, and here we can see the functions gamepad button check. And if I middle click here, it will explain how it works. And to summarize, it does a gamepad check, a number of the gamepad, which can be 0, 1, 2, or 3, I think, and the gamepad button. Let's copy this code here and let's put it here. Let's remove the if. If we middle click here, it will show the button codes for the gamepad. Here's the buttons, but there is a picture here showing the buttons better. And we can see GP pad for the D-pad and the GP face buttons. Let's use the gamepad D-pad now. We can also use the analog stick, but we'll do that in the future. Let's use the gamepad directions. So gamepad button check, GP, DP, I think. Let's see, GP pad left. And let's repeat that to all other buttons. Is this correct? Let's check. Yeah, it's correct. But here is like setting two values in the same statement, and this is gonna give problems. So let's put this or this. So this is like if keyboard or gamepad, one or the other. So if I'm pressing up on the keyboard or up on the gamepad, it will move up or down or left or right. I have a gamepad connected here, and we can move it with the gamepad, and we can move with the keyboard. And to finish today's video, let's fix his animations. He's like moving non-stop, so let's make him move accordingly to the directions you press. To fix his animations, we'll have to make new sprites because all of his sprites are always animated. So let's duplicate this sprite here and let's name it player idle down. And since it's animated, let's delete all of the other frames and make it one image. It's just this image. Let's repeat this to all other sprites. Now we have his idle sprites for down, side, and up. And let's change the object one. Let's name it O object player. This is the player object. And the sprite is set to the walking sprite. Let's change it to the idle down. If we run the game now, he will be stop, right? Let's check. Okay, he's stop. So how we make him animate from the stop to the walking animations? We have to go here, and the idea is to tie his movement to the sprite animation. How are we gonna do that? There's two ways we can do this. We can tie his movement to the keys that you press, or we can tie the movements to the speed, right? Let's check on a Bomberman game to see how it works. So in the game here, if I press down, you see that he keeps moving down. So the movement is tied to the keys that you press and not to the speed, because here his speed is 0, but he's still being animated. And it's actually taking differences. If he's like stopped, his animation is slower, and if he's moving, the animation is faster. So let's repeat that in the game. In order to keep the project organized, let's make a comment here by adding 2 slashes and putting animation. This line is not detected by the game, and you can type anything you want. You can put x plus 25 and nothing will change because the game will skip lines of code that starts with this. So let's put it animation, and this here is the animation code. If you're pressing the key right, it will change the sprite index to as player walk side. This function changes the sprite of the object to the sprite that you determine. So if you're pressing right, he'll walk to the side, pressing left, walk to the side, up and down. Let's test it and see how it works. So if I press left, if I press right, if I press down, and if I press up. There's two problems now. If I stop pressing the buttons, he'll still be walking. And if I press left or right, if I press right, he won't change the sprite. He was always walking to the side. How do we fix this? To fix that, we'll be using a function called image x scale. We'll be setting it to -1. Let me explain how it works. If you middle click here, it shows how image scale function works, but I'll explain in a picture software. Here we have the sprite, and if we flip the sprite like this, it flips to the other side. So this is image x scale set to 1. This is 0.5. This is 0, minus 0.5, and -1. So we'll be setting the image x scale to -1, and this will flip the sprite to the other way. And if we test this in the game now, left and right. Now he's walking, but look, he's not changing to the other side anymore. To fix that, let's put the image x scale on the other command too, but we'll set it to 1. Let's check it again. Now he's moving to the right, now he's moving to the left, but he's not stopping. How do we fix this? We should add another statement. If key right, key left, key down, key up, if all of those keys equals to 0, if you're not pressing any button, the sprite index will set to idle. Will be set to idle. Let's see it now. Well, he's stopping now, but he's not stopping in the direction he was moving. And to do that, let's organize this better. We'll bring it to here. Open more so we can put more statements. Let's get rid of this and let's put this. If the sprite index is walk side, it will change to idle side. If it's walk up, it will change to idle up, and walk down to idle down. Let's check it now. If I'm walking, he's walking. If I stop, it stops perfectly. Pretty good, right? I think we're finished by now. We went from that ugly thing with that tiny Bomberman walking blazing fast to something that looks much more closer to a Bomberman game now. And that's it for today's episode. Don't forget to vote in the poll, and I will see you soon in the next episode.